Okay, so matching. This is still the covariant adjustment. Instead of the predicting the count factor using machine learning or any prediction model, instead of that, we creating a count factor using the data I have. So matching means it's a matching this way. Instead of creating the count factor, we found each other's count factorial twins. So I just make exactly the perfect. What we're gonna do is a count factor of this one. Count factor of this one. We use the result of these guys. Okay, and then count factor of these guys. We use the result of that guy. So instead of the predicting the count factor, so we just use the someone who is close. This is like an X attribute. So we are looking for if this is a patient, we are looking for the similar patient, similar age and same gender, similarly not exercise, something like that. So all condition, of course you cannot find someone who has exactly same condition with that patient, but among the data we have, you just looking for the closest sample. And then using that closest sample data's result as our count factor data. So this is like a perfect match, but sometimes it is possible, right? I will give some example here. It is possible here if we have something like this, right? And then red one is somewhere far away here. Then what could happen is this one's count factor will be this one, right? Because this is the closest. This is closer than this one. This is far away. This is closer. And this one also, this is closer. This is far away. So this one's count factor will be this one, right? And then red's count factor will be this is closer. So red one choose this one, right? And this one's count factor will be this one. So it's not perfect matching, but this one has a match with this, and this one also match with this, but this one only match with this. This one, even though this blue one use a count factor, this one, but actually this red use. So it will not be clearly the matched group. We will look at the individual, the observation, and then using the closest. So you just think about like a matching is happening, not considering everybody. We just find the match one individual by one individual. So same data point can be selected for the count factor from the multiple different points. That's possible. So this is a N1, the 1NN matching. This NN is a nearest neighborhood. I don't know you took any machine learning or data analysis class. There is the method, is the KNN method, the machine learning. This is the K number of nearest neighbor. When we just predict this is the classification machine learning. When you try to classify, new data comes in, and then you put that data into the new observation. We don't know what is the classification. I'm trying to classify this new coming identity entry. So you put that entry into my data, and then you find the K number. So usually it's like a 5. We usually use an odd number. So 5 or 7. K equals 7, KNN means we find out all 7 nearest neighbors, and then we count how many of them are 1 and how many of them are 0, and yeah, we can decide the more popular one. So if there is like a 5 ones and 2 zeros, and we predict that this new entry will be classification 1. That's a KNN method. It's machine learning for the classification. It's pretty simple method. But this method, what we are trying to matching is it's the same as a KNN, but K equals 1. That's why it's a 1 and n, nearest neighbor matching. So we have to find out how we're gonna measure the distance. This is the metric distance. So distance can be a lot of different way you can decide, because this is not a physical distance, right? So we are just compare the patient to patient. Who are the closest patient? Has a closest condition. So this is like a age. Age you can calculate the quantity, but how can you measure the like a man versus woman? There's a lot of different way to define your distance. There's a lot of different way. When there's a mixture of the categorical variable and the numerical variable, how should we handle all the numerical variable? That's easy, but yeah, there's a lot of different ways. So you have to decide how you measure the distance. Here means how can you calculate this sample is closer condition than the other one. So you have to define it, and then once you define it and you find out who is the closest one, which data is the closest one. Of course, when we're looking for the count factor, so this is a blue, right? This is a blue dot. So I'm not looking at the blue dot, even though there is a blue dot which is closed here. Because I'm looking for the count factor, I'm looking at only the red one, right? Among the red one, who is the closest? This is the closest. That's why we use this one as a count factor. So we are looking for the argument is the minimizing the j's data point that minimize this distance, but treatment should be different. So if it's a blue, we are looking at only the red one. Among the red one, what is the closest one? And this is blue, then you are looking at only the red one. And if it's a red one, then you are looking for only the blue one. That's what this means. Is the treatment should be different because we are looking for the count factor, right? So you will get this one. The J is actually the count factor here. This is the count factor. So when treatment is 1, we observe the real result of the T1. This is the T0 case. This is a counter factual, right? And when treatment is 0, yeah, we observe the treatment zeros, but this is a count factor. Factual. So since we can estimate our count factor, so using that number, we can calculate the individual treatment, and then if you just calculate the average, then you can get the average treatment effect. So once you find out the count factors, simply you can just calculate the average and average, and yeah, then you can calculate the average treatment effect easily. Problem is, our estimation of the count factor was accurate. Yeah, of course it will not. So matching is interpretable, so easily you can see what's going on. When this work pretty well in the small sample side, and then this is non-parametric, so we don't need to control anything, right? And this is also heavily relying on the underlying metric. So this is how you define the distance. This depends on that. Could be misled by the feature which don't affect the outcome. So actually, when we measure the distance, right, we have a lot of different. Let's say x1 affects the y and x3 affect y, but x2 doesn't have any relationship to the y. Okay. But when you calculate the distance, we don't know which one affects which one, so we just make a calculate distance using all three variables, right? Then actually we should take it out x2. So x1 and x2 are pretty similar. Then we should have that one as our count factor. But because of x2 are a lot different, so we consider that is far away, right? So we are choosing the wrong count factor. That's possible because of x2, even though x2 doesn't affect the y. So we should get rid of x2. But when we do the analysis, I don't know which one will affect which one. So if you include all x1, x2, x3, so that's the feature which does not affect the outcome. In this case, is x2. Because I added x2 when I calculate the distance, real count factor, really close condition, the count factor can be calculated far away because of x2. That's what it means. It could be mislead. So matching is a variant of the covariate adjustment. Anyway, the covariate adjustment, yeah, as I told you, the KNN is K nearest neighbors. So remember, we estimate count factor using any machine learning or regression, any prediction model. So if we use a prediction model KNN and then K set it 1, then this matching method will lead exactly same result as the covariant adjustment with the KNN as a predictor model, right? So if you think about it, this is a clear matching is equivalent to the covariant adjustment using the two KNN nearest neighborhood classifier. So this is a prediction model. Okay, using the matching count matching data as our count factor result, or I can just generate the count factor using KNN method. Actually, your result will be exactly the same.